color based image clustering using dynamic programming. I am going to give lecture on this topic. Next, the content is abstract, introduction, problem statement and algorithm. Next, abstract. What is clustering? First, clustering is a grouping of objects based on color, based on various features. Image contains many number of features. The pixels having same color are grouped into one clusters. The image consisting of number of pixels. For efficient processing, this problem is solved by dividing the problem into sub-problems, and the solution of the sub-problems are combined together to get a solution of a whole problem. Hence this color-based image clustering problem is solved using dynamic programming technique. Next, what is clustering? Clustering is actually we are grouping the objects into we are actually grouping the object based on the features of the image. Image may contain many features: shape, size, color, and some other features may be the factor of grouping the image. So firstly the features are extracted and the grouping is done. The feature can be size, shape, color, etc. This I have already told you. Next, what is dynamic programming? Dynamic programming is actually when we have a large problem, we can divide the problem into sub-problems, and the solution of the sub-problems are combined to get a solution to the whole problem. But what is the difference between divide and conquer method and dynamic programming? Divide and conquer method is actually we are dividing the problem into sub-problem, but the solutions are independent solutions. They are not, their sub-problems are not interdependent. But in this case, in dynamic programming, the sub-problems are interdependent. The solution of each problem is dependent on the solution of the previous sub-problems. So here we have to store the solution of each and every sub-problems in the memory to get the solution of whole problem. Next, problem statement is here we are trying to cluster the image based on the color of the pixels. Here color features, we are concentrating on the color feature of the image. So each pixel's color is extracted, and based on the color feature we are grouping the image, grouping the pixels into clusters. Next, now what is our algorithm? Algorithm is actually, suppose we have taken a very small example of 6 by 6 pixels, but image may contain many number of pixels. So here we have taken 6 by 6 pixels to understand the problem. So we have divided the 6 by 6 pixels into 4 blocks. Block number B1, B2, B3 and B4. Block number B1 means here 1, is written as, actually it is denoting the coordinate of the pixel. 1, 1, 2, first row, first column, first row, second column, like this. So here B1 block contains 1, 1, 1, 2, 2, 1, 2, 2, 3, 1, 3, 2. So this is block number 1. Similarly, we have divided the whole image into 4 blocks. So every block is processed individually, and colors are extracted, and then grouping is done. So suppose we have a sub-problem B1. B1 is a block. Next, for each block we are maintaining for each color we are maintaining a table block by block. Suppose here just blue color table is there, red color table is there, and yellow color table. The blue color table in block 1. Block 1 is indicating, it is extracting all the coordinate values which contains blue color. So here in block 1, 1, 1, 1, 2, 2, 1 and 2, 2 are the pixel coordinate having blue color. Similarly, for all other colors we have extracted the pixel coordinates. Next, so for each block is processed in a similar way, and we have the color table as blue color table. Block 1 is just see the row block 1, it is denoting 1 1 1 2 2 1 and 2 2. So similarly for all blocks, all pixel coordinates are extracted. So for red color table, yellow color table, similarly we have extracted all the pixel coordinate value having that color. Next. Now after extracting the color wise pixel coordinate value, we have to find out the clusters because in every block is having all the having some color wise clusters, and we have to extract now inter block values. So here in the previous slide we have shown the sub-problem solution of each sub-problems are found and stored in the memory. Now next we have to find out the inter-block color values. Suppose in block number 1 the coordinate value which is having red color may be continued with the block number 2 also. So here this is processed in the algorithm for this step. To process this is, first the blockwise pixel coordinate having similar color value are found, which is shown in the previous slide. Now blockwise color groups are to be found. So in block 1 the coordinate values 1 1 1 2 2 1 2 2 is having blue color, and we have to find out we have to find out whether we can keep all these coordinate value in the similar cluster or not. So for that we have to find out the difference in x value and difference in y value. For 1 1 and for 2 1, difference in x is 1 minus 1 is 0 and 2 minus 1. Y value is 2 minus 1 is also 1. So here the difference is less than equal to 1. So this means that both the pixel coordinates belongs to the same cluster. And for 2 1 2 2 the difference is also difference in x value and y value is less than equal to 1. So here we can say that all these 4 coordinate values are in the same cluster. We can keep all the 4 coordinate value in the same cluster and named as cluster 1. Next slide. And block number 2, the block number 2 contains coordinate value 1 5 2 5 3 5, and here also the difference is less than equal to 1. Therefore all the pixel coordinate belongs to one cluster named as cluster 2. Similarly for before keeping these pixel in cluster 2, check whether it belongs to cluster 1 or not. So the pixel 1 5 is checked with 1 2 and 2 2. Similarly the remaining pixels are also checked, and no pixels belongs to cluster 1 and can be named as cluster 2. So here block 3 the pixels 5 3 6 3, the difference is less than equal to 1, therefore kept in cluster 3, as it does not belongs to cluster 1 and cluster 2. So every time we have to check whether it belongs to cluster 1 or cluster 2 or not. The pixel 5 4 and 6 4, the difference is less than equal to 1 and therefore can be kept in same cluster. First check the existing cluster 1 2 and 3. With cluster 1 and cluster 2 the difference is greater than 1, but with cluster 3 difference is less than 1, hence these pixels can be kept in cluster 3. Next, the pixels 5 6 and 6 6, the difference is less than equal to 1, therefore kept in same cluster. First check with the existing cluster 1, cluster 2 and cluster 3. With cluster 1, cluster 2 and cluster 3 the difference is greater than 1, hence we cannot keep this coordinate value in this cluster, so we have to create a new cluster. Finally for blue color, clusters are obtained, 4 clusters are obtained and the coordinate values are kept. Next. Similarly red color clusters are obtained and yellow color clusters are also obtained in the similar fashion. Suppose in yellow color cluster the pixels with same x value and same y value are grouped together, and the pixels 3 1 and 3 2 are same having same x value, and the pixels 4 1 4 2 4 3 4 are grouped together. The pixels with same y value are 3 1 and 4 1. Therefore, the pixels 3 1, 3 2, 4 1, 4 2, 4 3, 4 4 are kept in one group. The pixel 5 1, 5 2 can be grouped with 4 1, and hence all these pixels are kept in cluster 8. Next. So pixel 1 6, 2 6, 3 6, 4 6 are in same column, having same column, and the difference in x value is less than equal to 1, therefore kept in cluster 9. So in this way we have broken the image into 9 clusters having, and each cluster is showing a color value red color, blue color and yellow color clusters. Next. So conclusion is, we have divided the problem into sub-problem. Sub-problem is actually, in this case the sub-problem is blocks, and each blocks are separately processed, and the solution of each color groups are found, and the solution of each block is then combined to get the solution of the whole problem, that is in the form of clusters. The color based image clustering is done using dynamic programming. This is how we have solved this problem in using the technique dynamic programming approach. There may be many more methods for very specialized method for image clustering, like labeling method, connected component method, boundary value analysis method. Many more methods are there, but here we have taken a very small example for dividing the image into clusters. So thank you very much.